So I'll explain the funny name above Httpsession replacer later. My name is Nenad Bogojevic. I'm software architect at Amadeus for e-commerce, data-driven, container-based platforms, and those are icons of some of the things I like to do. The company, Amadeus, is actually a large IT provider for the travel industry. For those who came by plane, there's a very high probability that you've used Amadeus services even if you don't know. We're basically business-to-business company. We facilitate travel of 1 billion travelers a year, process 500,000 requests every second. This morning, there was a talk about databases. They are 50 years old. Amadeus is actually an IT industry which is older than that. It goes from early 60s. And we are a youngster. We are only 30 years of age. We started using Redis fairly recently, 2 years ago, but we really liked it. So we liked it so much we come with 2 presentations here. One about the client side, which I'll be talking today, and another one, which is tomorrow, about running Redis in Kubernetes and OpenShift, which will be presented by my colleague, Cedric. We're introducing actually an open source component to manage servlet sessions using Redis in any J2E application server. And it's present here on this location GitHub. And actually when I started writing the presentation for today, I got panicked here at this slide. Because basically that's all I have to share with you. We actually created something, which I think it's really nice. We open sourced it with quite a lot of documentation. And actually the best way to go is just to go there and go and see a README, because showing the README there and showing how sessions work on J2 application servers is not something very visually attractive. But you have came to attend this presentation. So I said, well, they want to be here, so I printed 50 slides for you to show. And as sessions are quite old, we'll do a presentation like in 2001 using Comic Sans and all things like that. Okay, just a short one. Java, J2E servlet sessions, as they were called in early 2000s, as a way how we can identify user in Java application server on a website over multiple requests, and we can store information about your user, and this information can be technical or can be security or can be functional. And all the application server out there, Tomcat, JBoss, WebSphere, WebLogic support this, and many of those, especially commercial ones, support some high availability features. Like if you have sessions on one server, that server goes down, it can fail over and retrieve the data from another session, from another server. An API, which evolved over the time, but it's basically a hash map. You have a set attribute, you have a get attribute associated to a session ID. There's actually a rich API around the session lifecycle. Session is created, has it expired, if the elements have been added, if there was a failover, so if it goes to another server, there's a lot of API present in the servlet standard, and of course you have propagate a session, and there are a few standard ways of propagating session ID, URL, or form parameters. Okay, so far so for the presentation of 2001. Let's go back to the present. Why Amadeus wanted to use Redis, and how it came Redis and J2E sessions in Amadeus. We have 100+ web applications, and we have hundreds, actually closer to thousands of J2 application server instances running in our data center. And our applications are serving some major Ireland websites, serving professional products which are used by travel agents or by airline agents at the airport. And we also have a business-to-business offering for the corporations that do travel. We're serving 2,000 shopping requests, which is something quite more complex than a simple web request, because we have to collect a lot of different information about prices. It's when you go to a website and you go and choose what flights you want to take. We started developing this things in Java almost as old as J2 is. So we started in 2001. So there's a lot of code, some old, some new, using many, many different libraries. And we also have several application servers. So we actually have in-house WebLogic and JBoss and Tomcat and some others. For us, always the problem was the JVM heap. JVM servlet sessions are stored in Java heap for the best performance. We won't have them in memory. However, in an airline commerce world session, a user actually accesses page rarely. It's not like Facebook. It's not like a social site where you have to put the updates all the time. You actually go and you search for the flights and you have your screen, and then you look at the price and you look at the times, and it takes a long time for a person to select one and to go to the next page. So actually for us, it takes several seconds and minutes between user clicks. And during all this time, the session is in memory. It's not removed. Garbage collection cannot liberate the memory. So basically we have an old gen inside JVM heap, quite large, and it's actually impacting the performance of this. And it would be really great if we could move them elsewhere, which actually was possible. There are lots of different solutions out there, so we can move them off Java heap. We can put them in native memory. That kind of works if you can do vertical scalability, so you increase your memory on your servers. That's not what we are doing in our company. In our company, we are doing exclusively horizontal scalability. We add new instances if we need to add more capacity. We can move them off machines. We, for example, in a database, which is possible in SQL database since inception of the sessions, but it's slow. Memcached had a bad failover. There are lots of Java data grid solutions that are actually working, fairly well. There's some other solutions, and we also had a look at Redis. And the first time we had a look is in 2012. Java session looks a lot like a hash in Redis. It's a set attribute, which is set, and the get attribute, which corresponds to get. However, we have all this session expiration, session listeners mechanism, and we want horizontal scalability, which at the time was possible using some client-side hashing, if you use the correct library, or you can use a twem proxy, which is a proxy to do Redis instances. But you would have, in this case, always to manage your Redis cluster, your Redis instances. You have to put something in place. And at the time, in 2012, I said, OK, that's not really a solution for us. There were other solutions in the industry. The one well-known is a Spring session, which is a great solution. It only works with Spring, and only with certain versions of Spring. It's not fully compatible with HTTP sessions, and actually many functionalities that we would like to have were missing there. And there were some other solutions for commercial open source, but they required to change the code of your application. So we have hundreds of web apps, and it was not something that we are keen to do. Also, we discovered, or actually we knew, that we have sessions elsewhere. We have quite a lot of C++ and some Python code in our backends, which represents 70% or 80% of our code. And we have different layers of sessions. We have sessions on an enterprise bus. We have sessions in applications or context or different names for how we call them. And we're thinking, I have all these Java application servers and this in-house C++ platform, and it would be great if we could manage all the session stores in exactly the same manner. So in 2015, we actually had a second look. There were some things that were going on. We were moving to the container-based platform, to Kubernetes, and we started looking, again, can we manage sessions differently? And also the Redis cluster was out. So the first thing is session expiry notifications could be managed, because now we had notifications in Redis since 2.8, and there's a Redis cluster. since 3.0. So still the sharding part is done on the client side, targeting different Redis masters, but everything around the failover, around the replication is managed natively by Redis, and it was a great step forward. So we said, it's great, let's go and implement this one. And the first thing we had is, how do you update 100 applications to use that? Particularly, so we use several frameworks. Also, our clients consider some hidden features like how do I propagate JSession via cookie as a part of the API. There are corporations out there that have the internal sites which will forbid receiving another cookie which was not whitelisted before. We have customers which were using not REST, but HTTP APIs, which are using JSession cookie as a part of the API. So we had to preserve that compatibility with our customers, especially in the airline industry. Customers are not very fast to moving to new technologies or the new APIs. And then we had WebLogic and JBoss and Tomcat and some Jet instances inside our company, and would really like to operate all those in the same way. So that's why we brought in Httpsession replacer. We are a business-to-business company, so we are not great at giving fancy names. They have to be descriptive, and though this one replaces the sessions. And we decided to make, to provide management for Redis, for sessions in Java application servers through Redis by inspiring ourselves from Spring Session, providing our code, but making it compatible with Servlet 3.x, Servlet 2.x, because we have some older applications, and to make it as transparent as possible for all the code. And that basically means zero modifications of any functional code or any build, and just adding maybe a few options when you start application containers. Full compatibility to the Servlet standard, encryption, because as we operate e-commerce, we actually encrypt a lot of data inside the sessions, and providing, of course, monitoring because you want to know. And finally, we actually wanted to make this open source. So replacing Httpsession in Java is fairly easy. It can be easily wrapped because Java has this feature of filters, and filters is something which is intercepting your requests into your web apps before it reaches your functional code. So in this filter, you can wrap the request and override the method which will actually provide a version which stores everything into Redis or retrieves in Redis. So it's actually quite easy and fairly simple. That's what most of the solutions which exist out there actually do. However, what happens is that application server remains the owner of the session, meaning that it's the one who generates the session IDs, it's the one who generates who manages the failover, who manages the callbacks for session expiry. So if you want to have IDs which are persistent, you still have to manage everything you used to manage in a regular approach. You have to put in place a cluster of application servers, and you still have to manage one way on JBoss and another way on the WebLogic. So we really wanted to replace those things to be the owner of all the elements there, expiry, ID, the generation ID changes. And we said, okay, that will be a piece of cake. So just for the illustration, a little bit, it can start easy. We said the session in Java is almost the same as a hash in Redis. So you have a request coming on your application server. You will create your session ID. You will have attributes of that session, and that can map to any of hset, hmset, or hdel calls to the Redis. So that's what we do. We actually map the attributes to Redis elements, and we add few metadata like when the session was accessed, when was it created, and we manage the expiration. We say session will expire on a day max inactive, which is the day when that instant when it should expire. Actually 5 minutes later, because if you do cleanup, you might want to retrieve the session before it. The session is stored in memory during the request for the best performance and committed at the end of the transaction. in reality, you could do that transplant. You can do the hset or hend all the time, but it has an impact on the application. And anyway, actually, the standard says that the session is committed only at the end. Then we want to manage the expiration. And luckily, we have notification now in Redis. So we create another key which is basically only serves to generate a notification event from Redis, and from which we subscribe from a thread on the application server. So notification events are great. They come. You can react on it. You can say this session is expired and trigger all the listeners and everything there is. The thing is that Redis does not guarantee when this will be called. It could be called immediately if it doesn't do anything, or it can be called later when actually Redis does clean up tasks and liberates the memory. So in order to be sure that the session expires, and because you don't want to expire 5 minutes later, there is another key which provides, which is called swipe, which is basically retrieved every 60 seconds, and it contains all the sessions that should have expired a minute before. All of this is actually almost a verbatim copy of how Spring Session, for example, works. But there is another thing in J2 application servers. It's the session stickiness, which is actually part of the standard for a server, which say that a node that created the session should be the node that handles all subsequent calls to this session. So it's basically standard says that application server, Java application server has to be stateful. And there's a reason for this. So any subsequent call will come to the same server. If the node goes down, then it will go to another server, and then we'll have the failover, and only that. Then the second one will become the one who has to handle all the requests. Why is it important? It's important because it allows managing of concurrent calls. You can have 2 requests for the same session coming on the same, coming at the same time, and it's much easier to manage concurrency on a single machine than across a distributed set of machines. So one thing what can be done in this case is like optimization. You do commit only when all the parallel transactions are committed or things like that. But the most important thing is to allow this easy management of concurrency. And we also want to manage the expiry. The expiry should be run on the server who is the owner of the ID. So we need to add the owner ID of the session into metadata. When we expire, we only expire the sessions which are on our node, but now we have to add another sweep, which because basically our node may have went down. So another node has to do a failover and expire of this session. And if you add this another sweep, we have to add another thread which is listening to it, and basically it means that's a kind of a little bit complicated. Basically what I saw that just doing this management of expire in a distributed environment adds 10 Redis commands just for the management, actually more than 10 commands just to manage it. So we looked, can we improve the performance of it? Can we do something which makes it, reduces at least number of round trips? So Redis has a pipelining which is great and works with Sentinel or single mode or Redis Enterprise, where you can actually send all these commands at once, get one response back, but doesn't work with Redis cluster. It doesn't work with Redis cluster because you have there 4 different keys, and they may fall on different servers. So you cannot actually pipeline. You can pipeline only per server, per master in Redis cluster. So we're thinking, can we do it somewhat simpler? And there's another, so we tried actually 2 strategies. One is called sorted set, which basically is a sorted set, which contains a list of all the sessions and when do they expire, and just one command sent at every request to application server. And then there is a special task which is running and collects all the expired sessions before now and expires them. But the thing is, this one is not working with session stickiness because it actually has no notion of it. So there's an improvement. We can do it. We can add the node ID. when we store in a sort session, we can retrieve only those sessions which have recently expired in our task, expire those sessions, and then we'll look for old sessions, some really old, and if they didn't expire, it means there was no server to handle it, so we manage those. Much simpler, reduces a lot of communication inside the Redis cluster. So this is an illustration how easy it was to manage timeouts in distributed environment. So are there other things which are easy? Choosing the Redis client library. There are 3 of those out there, let's say. There's Redis, which is a simplistic client. There is Lettuce, which is netty-based, which is rich async. And there's a Redis one, which is a hugely rich set of services, even including J2E sessions in Tomcat. For us, the main driver was dependencies. All the 2 low ones are using a lot of dependencies, have a lot of dependencies of other libraries, and Redis is really simplistic. And as we had these hundreds of web apps, each of them using their own set of dependency, we didn't want to manage dependency hell. We just went for the most simple solution there is. Then there is the question of filters. So filters are actually chain of execution. They have certain order and then execute in this order. But any filter can retrieve the session. And if we hadn't wrapped the session already, the filter would retrieve the session from the underlying application server. And that's not what we want to have. We actually wanted that we always provide the session for the application server, which basically means that the first filter out there should be our filter. The trouble is that the order of filters is not guaranteed. There's guaranteed in WebXML, but not if you add them inside application code. So what we did is we used the Java agent. So we said we don't want to modify existing code, but we want our filter to be the first one. So the only way actually of doing it is to modify the existing code. And using Java agent, you could actually modify your existing code at the runtime. What happens is that Java agent is loaded when your JVM starts, and it can look for all the classes that are being loaded and inject some bytecode. So that's what we actually do. We replace, in all filters, we inject the code that ensures that it's been wrapped by our Redis management code. And we also manage some other cases for the listeners, as we have to know about them in order to trigger them. And the result of that is that we actually don't have any impact on the application code. It's one-liner for the startup, providing this agent and no changes in the code. And of course, you have to eat your dog food, so we are actually running this in production. Sorry. So first, as I said, we support J2 containers, and we support basically all of them. Well, actually what we do is that at every time we commit, and we're doing all the development of this publicly, is every time we commit, we test at least at Jetty, Tomcat, and Wildfly. We test internally with WebLogic, which is due to licensing issue. And the important thing is that we don't strictly avoid having any code conflicts with application servers or with web apps, because we repackage all the dependencies, so they're not they're hidden from outside world. And when you run it, in case of a Jetty, for example, it will be a one-liner like there, specifying the agent and jar dependency. In some cases, some application server like JBoss, which is our main application server, is actually have more sophisticated management of class loading dependencies. So you have to create a module, which actually is produced by a library and has to be updated in the configuration of the JBoss. So now comes the question of configuration as configuring JBoss. How to configure that one? As we said, no code changes. Actually, all the configurations that were previously present in WebXML are still taken into account, which is basically, do you distribute your sessions? So do you allow sessions spread over multiple servers? What is the session expiry? However, there are things which are new, which are not present surely in existing code, which is what kind of Redis do I use, what kind of expiration I manage, and where my Redis is located. And those things are configurable either through agent or through the web XML or through system properties. Our aim is always to use as much as possible something which is from the command line, like system properties, rather than modifying the web XML. We also use the drop code metrics library actually from Drop Wizard, which is a great library for providing metrics in Java. And we actually provide, there's a subset, didn't fit on a slide, of the metrics there. When we first started loading this in our pre-production systems, we wanted to collect all the metrics there are, and actually it almost overwhelmed our metrics storage, so we reduced and we found what is most important metrics there, but you can actually measure a lot of things about the sessions, how many active sessions, the rate of their deletion, creation, as well as behavior with Redis. So Redis, it runs with Redis, and we want to support any mode of operation with Redis. So notably, what we call single, which is basically either single instance of a Redis or, for example, Redis Enterprise, and actually it works with Redis Enterprise solution. We also support Sentinel, and what we call our native way of working is Redis cluster, because we actually use this Redis cluster in Kubernetes. We're actually running this in Kubernetes and OpenShift, and that will be the presentation tomorrow. And this is an example for one of our clients. Okay, we have a set of JBoss instances, which are now stateless, basically stateless JBoss instances. They can go away. We can scale up and scale down in Kubernetes. We have a Redis cluster, and we have an operator, which is a pattern popular in Kubernetes, which is a process which is managing this Redis cluster. So it's managing the failover, the adding, and the removing of the servers. And there is, of course, provides quite a set of metrics. This is an example from one of our test runs. And we ran this in production. We ran this actually in production today. It's actually been great. As an experience. Our e-commerce application is dominated by the backend time. Latency is dominated by backend services, which would basically mean if we have 200 milliseconds response time, 130 or 150 milliseconds will be spent on the backend services. So by adding Redis on top, what we actually seen that it actually didn't provide any degradation in application latency. Principally, we assume that it's because the commit is done after the response is committed. And we also presume that a lot of, as you see, a lot of CPU has been reduced as we have much less memory usage. So coming to this, we also saw a significantly reduced garbage collection effort on the JVMs. With this one. By having all the sessions all the time offloaded and only present during the request, actually they are not present in the tenured, the old gen part of the JVM heap. So there's a lot more memory available for application to process. We have also seen an interesting thing is we run Redis in a configuration which is 3 masters and 6 slaves. So basically each session is present in Redis memory 3 times. And when we run the same thing on a Java application server, we would have 1 master and 1 replica. So I have 2. What we've actually seen is that by moving sessions to Redis, all the Redis instances were using 1.3 gigabytes of memory for a given user, while at the same time, all the sessions in the replica 2 would be using 1.8 gigabytes of the JVM memory. So basically, by offloading, we're actually reducing our physical memory consumption inside our clusters. Another thing that we experience, and I mean everyone knows about that Redis is extremely fast, is how little CPU it uses. So we loaded, and we actually migrated 2% of our traffic, so 2% of these 2,000 transactions, and we assigned 9 CPU instances to Redis, and we were using 1% of the CPUs of those. So which basically meant that we could migrate all of our traffics with 9 CPUs, and today probably we run number of CPUs used for sessions on Java side is in hundreds. So it's order of magnitude faster. We'll surely not be doing things like that. We'll probably have more instances of Redis, some more CPUs, but this is very interesting. And failures. That's all idea of having this session replication is to be able to manage failures. And failures do happen, and we have experienced failures with this one. And what's great is that with this one, statistically, we don't have more failures than before, and we have no more impact on the application than before. We have done the scale up and scale down, so adding, removing nodes, killing the nodes, JVM nodes, or actually doing new application load. The sessions would still be there and will still be available to JVM instances. The only issue actually that we detected was on a cluster failover, when a master was kicked out of the cluster and coming back into the cluster. There's a message sent by Redis, which is actually not very well managed by Redis. So we lost a few connections during this this kind of failover, but it's actually comparable to what happens when you have a failure of a JVM of an application server or a host of an application server, and then probably we'll be submitting pull requests for Redis to fix this behavior. So we give this back to public, to the community. It's available on the URL there. The license is made. MIT has a lots of documentations and samples, so feel free to have a look and to use it. And thank you. Any questions? Okay, depends on the customer. So the question was, how big are our session objects? Depends on the customer. When you talk about an e-commerce site, we're talking about a few tens of K. When you talk about the professionals, like travel agencies, we're talking about 1 megabyte of data in a session. Now, in principle, we operate our own data center. We do run some things in public cloud, but we operate our own data center, and we run this inside our own data center. So the question was, do we use it on Cloud Foundry just for No, we don't, but we have a feature inside which allows it. To add the compression, at the moment we only use encryption actually of the data. Any questions? Okay, thank you.